That's really fun.
This one-of-a-kind PVC flute was an experiment to test the intonation of the length of the instrument. You'll notice the instrument has 3 different bodies, each a different length. On each body, the finger holes have been made different sizes. There's a small, medium, and large. The head joint has been sealed at one end with a PVC cap. On the other end of the head joint, there's a PVC 3/4 inch extension that connects the head joint to the rest of the bodies. The hole in the PVC head joint has been drilled and filed to accurately reproduce the tone of a flute. Throughout this experiment, tests were done to determine the intonation of each individual body on the flute. The observation was that the body with the largest holes seemed most in tune with itself. The body with the smallest holes seemed most out of tune. This is most likely due to the fact that the smaller holes on the instrument require more precise measurements and drilling. The larger holes, because they have more surface area, can be a little less exact and still maintain a nice semblance of intonation. The hole spacing on the flute is a little uncomfortable, and it can be unsettling to play. This is why modern flutes have designed better and more accurate finger placements and fingering systems. The flute is made from 3/4 inch PVC piping with a standard wall size. These are all of the tools that were used in the production of making the PVC flute. On the left side, we have all of the construction components, and on the right side, we have all of the cosmetic components. On the left side, we start with our metric tape measure, along with a T-square to mark and label holes. In order to fix the cosmetic inconsistencies, we use sandpaper, tape, acetone, and 4/0 steel wool. The sandpaper cut most of the cosmetic inconsistencies while the steel wool smoothed everything out. Here's a demo of the flute. Now let's take a look at a waveform analyzed inside Raven. As you can see, this is the original waveform of a fluctuating sound that Elliot played. The tone is most definitely periodic, and the period and frequency can both be measured as they are accurately displayed on the timeline. Next, let's take a look at the spectrum. As you can see, there's a pretty clear fundamental frequency that's peaking at around 400 Hertz. You can observe all of the harmonics. I've turned the resolution up to 16,845. This picture shows a pretty clear image of the frequencies involved with the overtones in the PVC pipe. After analyzing similar sounds from the other lengths of pipe, all of the frequency curves look the same. Lastly, let's look at the spectrogram. The spectrogram has a bold yellow and orange line running across the bottom, which shows frequency over time. And there are a lot of lighter blue marks that indicate higher frequencies. This is a good way to show that tone is consistent throughout the playing of the flute. Lastly, here's a failed attempt at me trying to play the flute. Enjoy. Thanks for watching. This has been a fun project, and it's been extremely educational.